In this video, let's take a look at circumcenter. It's a special type of center of a triangle. The perpendicular bisectors of the sides of the triangle intersect at a point called the circumcenter. So let's fill that into our notes. The perpendicular bisectors of the sides of a triangle intersect at a point called the circumcenter. The circumcenter is always equidistant from the vertices. I think I need to spell it like that. So from each vertex, it would be congruent. So in other words, we have BP, CP, and AP are the perpendicular. The circumcenter, is equidistant from those vertices. So if A to the circumcenter P is congruent to BP, which is also congruent to CP. It says list the perpendicular bisectors. So those are the ones that have that 90-degree angle and they're bisecting each side of the triangle. So let's list DP is a perpendicular bisector. And, whoops, did I erase? Let me see. EP is another perpendicular bisector. Notice that those two pieces of that side, like BE and EC, are congruent. So let's list EP was another perpendicular bisector. And PF is the third perpendicular bisector. So it's perpendicular to that side and also puts it into two equal segments, AF and FC. All right, so DP, EP, and FP are the perpendicular bisectors of triangle ABC. Name the circumcenter, so that would just be the P that's right there in the center, and it says list all congruent segments. So I'm gonna try to keep this color coded. I've got segment AD is congruent to segment DB in blue, so I'm gonna write that down. AD is congruent to DB on that side of the triangle. Let's see, in orange, I've written AF is congruent to FC. So AF would be congruent to FC. And in purple, I've got BE is congruent to EC. And then last but not least, the perpendicular bisectors were equidistant to the vertices, or like the circumcenter is equidistant to the vertices. And I wrote that in red, so I'm going to include AP, BP, and CP are all congruent to one another. So AP is congruent to CP is congruent to BP. They're all equidistant from the vertex to the circumcenter. Lots of congruent segments for this one. So let's look at example 1. If Z is the circumcenter of triangle TUV, find each missing measure. So first they told you to find TU. So looking at the figure, TU would be this entire side of the triangle. And we know that this is a perpendicular bisector that meets that side, because they've told us we have a circumcenter Z. So we know that TX and XU are equal, and they would both be 19. So the total TU would add up to 38. All right, so then they asked for VY. So VY is on the side over here, and they've told us the total of that side is 34. We know that's a perpendicular bisector, so that means that each part of that side would be half of 34, which is 17. And then they asked us to find UZ. UZ is from the circumcenter to the vertex, and we know that ZV would be equal to that because it's also from the circumcenter to the vertex, and those are equidistant. And so we know that ZU or UZ would equal 21 as well. All right, so then they asked for WV. And we know that we have a hypotenuse of that little right triangle that equals 21, and we have one side equals 15. So we need to do the Pythagorean theorem to figure out the missing side. So I'm going to say 15 squared, and B in this case is going to equal the side that I'm looking for, which is WV. and then the hypotenuse was 21. So 15 squared plus b squared equals 21 squared. Now let's use our calculator to help clean that up quickly. So to solve for b, we can go ahead and just subtract 15 squared, and we would have b squared is equal to 21 squared minus 15 squared gives us 216. So then we just need to take the square root of 216. And so we end up, I wrote 218 by accident, hold on. Let's write 216. Then take the square root of both of those, and we get b, which is the side that we were looking for, was 14.7. Let's just round to the nearest tenth. So if that is 14.7, the last question they asked for was TV. So TV would be 2 of those because those are equal. So 14.7 plus 14.7 would be 29.4. All right, so that's it for example 1. Let's take a look at example 2. In example 2, it says if H is the circumcenter of triangle BCD, find each missing measure. So they first asked for GD. So GD is half of the side BD, and these segments would be congruent because we know that's a circumcenter, and so we know that's a perpendicular bisector from H to G. So then if this whole side is 24 and it's bisected, each piece of that side would equal 12. So therefore GD would equal 12. Then they asked us to find BC, and we know that half of BC equals 7. And so the other half would also equal 7, so BC would have to equal 14. The next thing was EH. So let's look what we know about EH. So I can see that they've given us this 13 for BH. That would be equivalent to CH and DH. So they would all equal 13 right there, which will help us to figure out EH. Because then we have this 90-degree or right triangle, and we can use the Pythagorean theorem to figure out this missing side. So let's say 7 squared plus b squared equals 13 squared, and we're calling b the side we're looking for, which is EH. B is just a little bit easier to keep up with in our equation. So let's go ahead and subtract 7 squared and bring down b squared would be 13 squared minus 7 squared. So let's type 13 squared minus 7 squared, and we get 120. And then take the square root of 120. So the square root of 120 is 10.95. So let's say 10.95 would be EH. And then they asked us to find FD. All right, so let's look and see what we know. We've got 3 as one side of that little right triangle, and we also know that the hypotenuse would equal 13 because HD equals BH, which we highlighted in yellow right there. So we have 2 sides of a right triangle. We can figure out the third. We have the hypotenuse and we have a leg. So let's say 3 squared plus b squared equals 13 squared. And the b in this case is our FD that we're looking for. So that's 9 plus b squared equals 169. And if we subtract 9, we get 160. And then we just have to take the square root of 160 to finish it up. So 160, the square root of that would be 12.65. And I'm just going to put it right there on the side of the triangle and over here on my answers. So 12.65 is the length of FD. And then they asked us to find CD, which would be the total. So let's just multiply that by 2, 12.65 times 2. And we get 25.3. All right, let's just look at one last example. The towns of Adamsville, Brooksville, and Cartersville want to build a library that is equidistant from the 3 towns. What is the name of the center of the triangle they should use? Great question. So we have Adamsville, Cartersville, and Brooksville, and they're connected by a triangle, and we want to put a library equidistant from the three towns. We would want to go from the vertex to that point and have those be equidistant. And the only center of a triangle that we've learned about that has that as the case would be the circumcenter. So the circumcenter is the answer to this question because, like I say, it's the only one that's equidistant from the center of the triangle to the vertices, which is where the towns would be located. All right, so that's it for a few examples on circumcenter.